technical knowledge have slowly but surely made him master of his environment. The products of man's ingenuity are truly remarkable, but no less amazing is the lowly spider, who for uncounted generations has been performing engineering wonders without anything resembling man's transit or plumb line, pattern or blueprint, without any tools except those which God has fashioned as a part of her body. There are an estimated 100,000 species of spiders throughout the world, each possessing a number of engineering skills that qualify him as a master craftsman. For example, the orb weaver, garden variety of spider, engineers webs in a most exquisite fashion. Her gossamer highways bridge leafy chasms with almost invisible ropes of silk, each of incredible strength, stronger in fact than steel of equal size. She manufactures her rope from silk glands in her body as she goes along. 6 spinnerets located at the tip of her abdomen release 5 different kinds of liquid from 3,600 holes. She can spin a single strand, a heavy cable, or a broad band. Under her careful control, the silk may be elastic or non-elastic, sticky or unsticky, colored or transparent. From it, she will manufacture foundation lines, guy wires, scaffolding, trap lines, signal cords, cases, baby cradles, balloons, kites, blankets, and cushions. In making its web, the spider first throws out a strong but narrow bridge. This becomes the base for the entire structure. The spider then spins a series of radiating spokes as a framework. And then, beginning at the hub of the spokes, it lays down a circular pattern of threads in an ever-widening spiral. The hind legs are used both to measure off the proper distance between the silvery strands and to place them into position. For man to weave his great aerial highways of steel and concrete requires the combined work of hundreds of engineers and many months or even years of planning. But the spider is endowed with the ability to perform an engineering feat that defies man's ability to fully comprehend. The spider's construction is accomplished without any previous training and without any evident blueprint or pattern. While waiting for some juicy morsel to blunder into its trap, some spiders will station themselves in the center of the web. Others, however, keep hidden nearby. When the trap is sprung, the vibrations of the insect's struggles are carried to the spider, which immediately rushes out to subdue its prey and carefully package it up for a future meal. On closer inspection, we find that the spider is not an insect at all. He is an arachnid, something very different. For one thing, the spider has 8 legs in place of the insect's 6. He has 2 body sections instead of the insect's 3. And unlike the typical insect, he has no wings or antennae. Now perhaps you're wondering how the spider avoids being caught in its own trap. Well, the reason is not hard to find. The web is actually made up of 2 kinds of silk. One kind is elastic and sticky. The other is inelastic and non-sticky. The spokes of the web, the framework, and the guy lines that support it are all of inelastic and non-sticky silk. But the spirals that connect the spokes are very elastic and stick to everything that touches them. The web is not the only example of spider engineering. Great skill is exercised in the construction of the egg sac, a silken ball which will protect the eggs and, later, the newly hatched spiderlings. First, a downy cushion is spun to cradle the eggs. When this has reached a satisfactory size, egg laying begins. The lustrous yellow cap grows hour by hour until some 200 eggs have been deposited. When all the eggs are laid, they are covered with strand after strand of silk. Having made this super nursery, insulated, waterproof, and furnished with the richest silks, satins, and floss blankets, the mother takes no more interest in her young, and she soon dies. Before long, the little ones will emerge from their cushioned comfort, and without being taught, will immediately begin to build miniature webs of exquisite beauty. Silk spinning is by no means confined to the orb weaver. There's a certain fat, grotesque creature known as the bolus spider. Now, of course, the word bolus refers mainly to a kind of lariat used by the Argentine gaucho. But long before the days of the gaucho, our little spider was making good use of the bolus. Chances are you've never seen her. For, like a great many spiders, she's active only at night. The spider forms her bolus by rolling up a little ball of sticky silk, which she hangs from the end of a strong silken line. Then she pulls herself up to a vantage point, catches hold of the bolus, and prepares to cast it at the first insect that comes within range. What it is that attracts the insect is not definitely known. It's possible that the reflection of light on the swinging bolus is part of the answer. Be that as it may, since the spider is ready and waiting, let's dangle a tasty morsel in front of her and see what happens. The spider makes use of a pair of built-in hypodermic needles to put her victim to sleep. She injects just enough poison to paralyze the prey, but not enough to kill it. That way, the food remains fresh. Later, the spider returns to feed by